Write a function is prime that takes in an integer n and returns true if n is a prime number and false if n is not a prime number. So here, by definition, a prime number is a positive integer that is larger than 1 and it is only divisible by 1 and itself. Here, some examples of prime numbers that we have are 2, 3, 5, 7, 11, 13, and so on. So these numbers are only divisible by 1 and itself. Conversely, some examples of non-prime numbers are 4, 6, 8, 9, and so on. So here, notice that these numbers can be divided by something other than 1 and itself. So do pause this video and take some time to give this a go before taking a look at the answer. So first things first, we use the def keyword to define is prime and we take in n. And here, we start to write our function body. So before we start writing our function body, let's try to break down how this works. So firstly, let's say we are given a number 12. And we need to check whether it's a prime number. And to do this, we need to list its factors. So factors is 1, 2, 3, 4, 6, and 12. So here, notice that we have these 4 numbers in the middle, which makes it not a prime number. However, to find this out in Python, we actually need to check this one by one. So we need to generate the numbers 2, 3, 4, 5, 6. And notice that I do not say 7 because 7 is actually more than half of 12, which means that 12 can never be divisible by 7. So here, we check that 12 divided by 2 is equals to 6 with a remainder of 0. So the moment we have a remainder of 0, we know for a fact that this is not a prime number. Next, let's say that n is equals to 13. And here, when we list its factors, we know that it's just 1 and 13. However, in order to find these factors in Python, we have to check 2, 3, 4, 5, 6 also. And here, once again, I do not check 7 because 7 is more than half of 13, which means that 13 can never be divisible by 7. So here, I'm going to check 13 divided by 2. So we get 6 with a remainder of 1. So 13 divided by 3. And we get 4 with a remainder of 1. 13 divided by 4, same. We get 4 with a remainder of 1. 13 divided by 5. And we get 2 with a remainder of 3. And 13 divided by 6, we will get 2 with a remainder of 1. So here, notice that none of the remainders are 0. So none of remainders are 0, which means that 13 is a prime number. So first things first, here we need to generate the correct numbers. So for I in range 2 to half of our n. So here we are going to write n floor divided by 2 n plus 1 because this number itself won't be included. So we have to add 1 in our range. So let's print I and let's check. So let's try for 12. And if we run this, we are going to get 2, 3, 4, 5, 6. And similarly, if we try for 13, we should also get 2, 3, 4, 5, 6. Next, we have to find the remainder when n is divided by our number. So here, n modulo I. So once again, modulo will find the remainder when n is divided by I. And so if we run this, we'll get 11131. So to make it clearer, I'm just simply going to put I here. So if 13 is divided by 2, we get a remainder of 1. If 13 is divided by 3, we get a remainder of 1. If 13 is divided by 4, we get a remainder of 1. If 13 is divided by 5, we get a remainder of 3. And if 13 is divided by 6, we get a remainder of 1. However, if I change this to a 12, we are going to see a bunch of zeros. So here, 12 can be divided by 2, 3, 4, and 6. And that is why our remainder is 0 here. So here, if n modulo 1 is equals to 0, this means that n is not a prime number. So the moment we reach a 0, we are going to return false. However, if we reach the end of our for loop and we do not return false, this means that, like 13, none of the remainders are 0, which means that n is in fact a prime number. So here let's test this, and if we run this, is prime 12 should give us false because 12 is not a prime number. And here we have it false. And if we run it for 13, we should get true. So next, let's print all prime numbers from 1 to 20. So for I in range 1 to 21, because 21 itself is not included, let's print I first. And we are going to get all of them in a row. So let's add a n is equals to white space. And if we do this, we'll get all of them in one row instead. So next, let's call our function. So if is prime I colon, and whatever happens here will be inside the if block. So here we are only going to print the prime numbers. And here we have it 1, 2, 3, 5, 7, 11, 13, 17, and 19. However, here you may have noticed that 1, which isn't a prime number, is included here. But by definition, 1 is not a prime number. So in this case, we actually need to write a if block here. So if n is equals to 1, we are going to return false. And so if we run this again, we are going to get the correct prime numbers from 1 to 20. So once again, thanks for watching, and hopefully this was clear and easy to understand. See you in the next one.